So welcome everybody. Pleasure to see so many of you here. My name is Jacopo Margutti. I'm a data scientist with 510, the data team of the Netherlands Across, as Fabian said. And I'm here to tell you something about one of our latest projects, which was specifically about vaccine misinformation. Now, first, a few words about our group. 510 takes its name from the surface of Earth, 510 million square kilometers, because, well, we are a data team and we aim to help the Red Cross movement anywhere in the world. Our purpose is to improve speed, quality, and cost effectiveness of humanitarian aid by using and creating data and digital products. It's a bit of a word salad, but I will give you more concrete examples on the way. We started 5 years ago now, pretty small, only 3 people, and we are steadily increasing in time. We now have about 30 people as staff, plus 65 more or less between students and volunteers, and a few other data teams that we helped establish within the Red Cross movement around the world. We don't only do data science, maybe that's good for the audience here. Data science is a small element in a vast network of competencies, so to speak, that are needed to effectively solve the problems that we face in the humanitarian world. So it's not only about the techie solution, but it's a lot about context, a lot about usability, a lot about many things. And all these skills are needed in our team to effectively make products that the Red Cross can use. So we are very proud that we have lots of expertise within the team. We mostly work with natural disasters. That's an important distinction for those of you who are new to the humanitarian world. The Red Cross works especially on natural disasters. And in our team, we prioritize what is called the disaster response. So immediately after a disaster has happened, all the kind of support that we can give to the people affected in any possible way, in any way that is needed. So that's where we focus most of our work. We support, as I mentioned before, the Red Cross around the world. These are called the national societies of the Red Cross for each nation. And so far we have supported 36. So I would say we connected with many people around the world. We embrace volunteerism. As I quickly said earlier, we have many volunteers in our team. I started as a volunteer, and we couldn't do the amazing work that we do without the support and hard work of all the volunteers that work with us. So we aim to have 5 volunteers for each staff. Well, we are a bit far away from that, but let's say volunteers are always welcome and are an important part of what we do. We use data responsibly. I guess this is important to mention, even because we're going to talk about that more with Kate later. That's an important aspect for us, especially because the people that we're trying to support, people affected by disasters, are especially vulnerable. So the last thing that you want is that whatever data or digital solution that you produce can be used against them or can be put them in an even more vulnerable position. So taking into account the context and making sure the data is handled safely, it's at the core of what we do. And we also try to make products, whatever we do, that are actually needed, usable, and useful for people. And in order to do that, we follow an approach which is called human-centered design. For those of you who come from an industrial design background, maybe know this very well. But the principle is, when you design a product, which can be something as simple as a dashboard, start from what are the needs of your users and what do your users can and want to use. That's the principle. Now, very quick overview of the stuff that we do. The way we like to present our work is to divide them according to the disaster phase. We have preparedness, that's, 2 years before the disaster. Early warning, that's immediately before a disaster happens. Disaster response, after the disaster happens. And, disaster recovery, months after the disaster happens. So these are, you divide as a function of time, the humanitarian response. For each of these phases, we have a stream of products. So if it's about preparedness, we talk about digital risk assessment. Why? Because if you want to prepare for a disaster, let's say our motto is try to do it evidence-based. Try to collect data on where is the risk connected to disaster the highest, where it's more likely to have impact, and prioritize whatever program you have accordingly. So use data to assess risk. If the disaster is about to happen, we can start talking about forecasting, what we call predictive impact analytics. So it's not about forecasting the disaster itself, like a typhoon, but forecasting the impact of the disaster. How many people are going to be affected, how many houses are going to be destroyed, because these are the concrete information that then the Red Cross needs to make a plan, a concrete plan on how to support the people. The disaster happens, we cannot prevent it very often. And then we need to support. We need to support the emergency response. Again, we do that with data and digital products, maps, whatever is needed. We are very flexible when it comes to emergencies, and our team is actually often deployed in the field as IT support or data management support, whatever is needed. And finally, for the recovery phase, but I would say throughout the whole disaster phases, we have a big program about what we call direct digital aid. This is basically to try to move the humanitarian response from giving goods like food or tents. We move it from goods to cash. So try to give cash to people so that they can buy whatever they need and we can support the local economy. It's a long story why this is happening in the humanitarian world, but we are trying to support these efforts by providing digital tools that enable to safely transfer cash from donors to affected people in a seamless way, avoiding extra costs and inefficiencies. Very quick overview, that's what we do. And we have many products for each of these categories, but I'm not going to that because we're here today to talk about something else. We're here to talk about how data science can help address vaccine misinformation. So yes, we're talking about that one virus that is making our lives so exciting in this period, COVID-19. And in particular, we're talking about what the Red Cross does when we talk about COVID-19. Probably you have heard, let's say the most visible activities of the Red Cross are those that concern support of patients. So in many countries, the Red Cross runs the ambulance services, so they transport patients to the hospital. They do the tests, the COVID test, PCR test, whatever, or swab tests. And in some other countries, they started already doing the vaccinations. So the Red Cross is in charge of vaccinating people. These are the most visible activities, operations that the Red Cross has. But there is actually one thing that, if you look at the numbers, is much more important, because that's what really what the Red Cross does everywhere in the world when it comes to vaccination, when it comes to COVID-19. That is maybe less flashy and gives less nice pictures, but that is communication. The Red Cross, one of the important role in every country is communication about the safety of vaccines, communication about the activities the government and health systems are in place for distributing vaccines, distributing protective equipment, protective measures, etc., etc. Pretty much everywhere in the world, the Red Cross is very active on these, either through call centers, helpline, or even, well, whenever it's safe to do that, by face-to-face, so going and talking with the communities about safe ways to deal with COVID. So since this is really one of the core activities the Red Cross does, we kind of decided to tackle this problem and see if we can support the Red Cross with their communication efforts when it comes to vaccinations. Now, needless to say, if we start talking about vaccines, I guess you've all heard all kind of theories and concerns about vaccines. And these are what the Red Cross has to basically, they have to help people understand what is going on with vaccinations. So we have many vaccines now on the market, and many people are wondering, are they really safe for us, or will I get sick if I get them? Are they really vaccinating people for our own good, or is there some, it's just a big political game, people are making money out of it. Many people also express these kind of opinions, and therefore they lose trust in the whole vaccination effort. Some people, they have very creative theories, for instance, that Bill Gates is putting microchips into vaccines so that they can use the 5G or whatever network to control our minds, so that the Illuminati can take over the world, right? So you can get very creative with this. All of these problems is what the Red Cross needs to face when they communicate about vaccines. So let's try to define the problem in a bit more systematic way. The Red Cross needs to know what are the main concerns, rumors, or fake news when we're talking about COVID-19 vaccines. Do they change over time? So what are the new fake news spreading? Are the opinions of people changing? Do we need to monitor this in real time? And where are these rumors spreading? So if we need to start a communication campaign, which areas do we prioritize, or which channels based on the area? If we know this, the Red Cross can address the right issues at the right time, in the right place. So more targeted and efficient communication campaign. So since we are the data and digital team, the way we collect rumors and fake news about COVID vaccines is through social media. That's where many people nowadays express opinions. And in particular, within the vast social media landscape, for this particular project that I'm presenting you, we focus on Twitter for a few important reasons. The user posts are publicly accessible, so you don't need permissions. Nowadays in Facebook, you do. You cannot simply get Facebook posts of everybody without their explicit consent. It's for free, so you can get all tweets for specific topics up to 7 days in the past. So if it's about real-time monitoring, it's basically for free. It has an easy-to-use Python API, which is, for the people like me who actually do the job, it's very handy. And Twitter has a decent uptake in the Philippines, where this project has been carried out. Almost 10% of the population, which might not seem much, but if you look at the numbers of social media, is actually a decent number. So usually, you never get more than, it's hard to get more than 50% in any country in terms of active users of social media. So this is a decent subset for the topic. I will get to limitations of this choice at the end of my talk. So I'm going to give you a quick overview of what this tool actually does. So how are we trying to answer the questions that I outlined before using this tool that we built? So we start by collecting tweets. Tweets are messy. So, there are user mentions, hashtags, emojis, and all this kind of stuff. So after getting tweets, you need to pre-process the text. So this means removing user mentions for safety issues to make sure that there are no problems with data privacy. We remove the hash from the hashtags. We remove the emojis, and at the end we are left with some clean text, which is easier to process by let's say text models or machine learning models. So we do three things with this after pre-processing the tweets. We geolocate them, so we want to understand which locations are you talking about, and this is what some tweets they already have the GPS coordinates. Some others we simply look for mentions of locations. In this case, we're talking about Manila. We do sentiment analysis, so what kind of emotions are people expressing in these tweets? Is it positive or negative? Are they positive about vaccines or are they negative? Do they express fear or distrust, or vice versa? Are they saying that vaccines are good for them? And we do what is called topic modeling. This is a clustering type of thing for those of you who are a bit more proficient in the topic. So we try to understand what are the broad categories within all my corpus of tweets, with all my big set of tweets. I'm trying to see if there are patterns, if there are groups of tweets which are similar to each other, so that I can make sense of everything that people are saying. We take all of this information and we present it in a nice dashboard so that our users, which actually is the communication team of the Philippines Red Cross, can use this information to plan their communication campaigns. This is a high level how this works. In terms of technology, since this is a data science meetup, so I guess maybe should give you a bit more insight. The dashboard is simply in Power BI. It's handy to use and host many services. The model itself is 100% Python. I will go into the models in the next slide, but most of the framework is in Python and it's Dockerized. So it's portable to any cloud provider that you might have. So it can be used by any national society, whatever the choice is. I don't know if you're familiar with Docker. It's simply a convenient way to take some code and make it reproducible on any machine. It's very simple. We use Azure. So this whole thing for us sits within the Azure cloud. It's our cloud service provider, but you might be more familiar with AWS or Google Cloud, whatever. You can run this thing within any provider, so to speak. So yeah, that's how this works. About the models, since again this is data science, so that's just a bit more details. Geolocations is based on mentions of locations, so nothing fancy here, just regular expressions. And it's we built a couple of scripts to do that. Sentiment analysis, we actually decided to use pre-made models by Google Natural Language. This is because they perform very well in our experience, and they are basically for free. So you can get up to 5,000 API calls per month for free, and which is for us is sufficient for the volume of tweets that we handle. And yeah, it's even relatively cheap for more. So I would say it gets expensive only if you have a major business where you really have millions of tweets every day. Otherwise, it's almost free, and it's probably higher quality than what you can custom build in terms of sentiment analysis. For topic modeling, we build ourselves, also because it's an unsupervised method. So having a big tech giant behind you doesn't really help too much. We based on this GSDMM short text clustering model. It's a very nice model for text clustering, which was tailored for short text, so tweets, Facebook posts, etc. So was suited for the task. One important mention is that after we do the clusters, in principle, what you could do is to extract the topic of the clusters by, what's called topic summarization. We don't do that because it's, we are on the process of doing that, but it's not in the operational version at the moment. So at the moment, each cluster is then analyzed by a human analyst who actually then makes sense, okay, what is the topic that has been identified in this cluster, and gives a meaningful label which is understandable by other humans. The problem with text summarization, it's hard to make stuff that is really nice to read. If you're familiar with the problem, you know what I'm talking about. So there is just a bit of human in the loop in the system to assign the labels to the clusters. So I just want to discuss main takeaways and limitations of this project as a sort of wrap up. So in our discussions with the Philippines Red Cross and throughout the whole project, we felt that yes, social media analysis can help them to tailor their communication campaigns regarding COVID vaccines, because very often they have little idea of, as I mentioned before, how important actually the various topics that you hear in the news are. We like the fact that it can be set up with minimum costs, which makes it scalable, which is concretely a real problem, because for many national societies of the Red Cross, especially in the developing world, they cannot afford to put thousands of euros in a fancy tech tool unless there is a clear value. And if you have to choose between life-saving interventions and whatever social media analysis, you don't choose this. So it has to be for free, or it has to be very cheap, which makes it scalable, which makes it adoptable, sustainable by the Red Cross around the world. Now, social media imposes biases, and this is important to realize if, for this application, for whatever you want to do. The kind of people that talk on social media Well, there is a demographical bias because the people that talk are younger than the average. There is a socioeconomic bias. The people that talk on social media are usually more educated and more wealthy than the average in a certain population. And connected to this, there is a geographical bias. So the people in social media are often people from urban areas, from rather than rural areas, or the countryside. So the snapshot that you get from social media is not necessarily representative of the average person in the country that you're studying. This is important to realize. And this is a fundamental limitation of using social media. There is a lot of research regarding these kind of biases. So I encourage you to look for stuff if you want to have a better quantitative understanding of what I'm talking about. Another limitation is that all these language models, natural language processing, sentiment analysis, they are not available for less spoken languages. So if you're talking about a country where you have many different languages spoken by a population, and maybe every population, every language is spoken by, say, 1 or 2 million people, it's very unlikely that Google or whatever, whoever is going to develop language models for these minor languages. So this is a fundamental limitation. Even basic services like Google Translate that we all know very well, they don't exist for many languages in the world. So, especially in the developing world. So, and this is another fundamental limitation. So in some contexts, this simply cannot be, machine learning is not there yet. We don't have the models to do this. But again, luckily, some languages are becoming more and more used. And finally, you might encounter personally identifiable information. Now, Twitter is maybe the least harmful example because the posts are public, so they, by definition, there is no sensitive agreements about data privacy because everything is public on Twitter. But still, we don't want to encounter the risk of exposing usernames, for instance, in our digital tool. And this is because you don't want certain opinions to be traceable to specific people. You want to avoid as much as possible the risk of certain people or certain ethnic groups or certain whatever minorities are going to be associated, in this case, for instance, with spreading fake news, right? Because this has consequences. So always take into account that when you work with social media, it's really important to plan ahead for anonymizing data and making sure that whatever information you provide is not traceable back to users. Now, the specifics depend on the project, but yeah, this is the general philosophy, I would say, to put it in simple terms. Now, the dashboard that we developed, unfortunately, is not publicly available because this fake news on COVID vaccines is a very sensitive topic, and the Philippines have also decided so far not to make the dashboard available, publicly available. The code is on GitHub, so I encourage you to have a look. And yeah, just take inspiration if you ever, might think this can support someone else, or you can have a different application of the same project. Everything that we built at 510 is open source, so have fun browsing our GitHub account. Thanks. That was it.
Excellent. Thank you, Jacopo. This is really cool stuff. We'll give it up for questions. I think there have already been 2 in the chat. Otherwise, you can also raise your hand and I'll call on you. I think Chiel, that was the first question. I'm not sure whether you want to ask it yourself or you want me to ask it.
Can you hear me?
Yeah.
Yeah, it was more related to the general part of your talk, so not about the fake news, but the disaster preparedness, etc. You take into account what other aid organizations will be doing, so you can look at what the impact will be. But if the Red Cross is maybe not the only organization that needs to do something or can do something.
That's a very good point. Yes, we do that as much as possible. There are mechanisms to align the work of agencies within an emergency response. I don't think we need to go into the details, but there are ways to align our work. Now, unfortunately, I'm going to be honest, this is far away from being optimal. So sometimes it becomes difficult, especially in the planning phase, to align with others on where are we planning to do what. But I see this is improving a lot in the humanitarian world. So this kind of collaborative efforts into optimization of allocation of resources are on their way. And we do our best to cooperate with whoever is willing to have a common discussion on the plan.
Yeah, because I remember that, for instance, in Haiti, it's quite a long time ago, with the earthquakes, etc., that a lot of money was collected in all kinds of countries, and then it took years, or maybe they're still not done yet, with helping people to recover. So everybody is more or less working next to each other and not collaborating a lot. Maybe it's a lot better now in different countries, but.
I was not personally involved in Haiti, so I don't feel I can clarify what went wrong there. But I can only say that, we're doing our best, doing what we can.
Sure, I'm quite sure. Thank you.
Okay, Merzad, I think you had one in the chat. Maybe you
Yes, I had a question. Just thank you. Very fascinating to see the model and how you set up the design. My question is about how you filter out fake data. You have a lot of, especially social media, as you mentioned. There's a lot of, just to give an example, automated bots and automated groups of people that actually create fake data on purpose. So how do you have a system or a model to actually filter out those type of information? And how do you handle biased information? Thank you.
It's a good point. And we don't have a model to filter, to classify procedurally generated tweets. We hope that Twitter does it for us. It's a complicated issue because it's very hard. It's not only about the text of the tweet. It's that can be very easily made impossible to discriminate. Like you can. There are systems that write tweets which are impossible to discriminate from a real human. It's a lot. Usually they detect it by network analysis. So this fake tweets account, by the specific pattern of connections that I have within the social network, you know that are more likely to be fake than not. But that's quite complicated analysis. And so we decided that was out of scope for the sake of this project. In a sense, it's also that we want to understand how much fake news are circulating. So whether they're circulating because of bots or humans, it doesn't change so much, right? The tweets are still popular, the hashtags are still trending. That's scary, but true. So maybe you also want to listen to what bots say.
Okay, thank you.
Paradox.
Okay, excellent. So we have Maya, Andrew, and me, because I don't know how to raise my hand, and then Chil and Gina. So take it away, Maya.
Okay, I think I should be there now, right?
Yeah.
Mm-hmm.
Okay, cool, thanks. Awesome talk. I had a question on the initial selection of tweets. So do you just take everything with #vaccine and, or do you use some sort of snowballing with the users and retweets? And how do you ensure that you get sort of do you also get a clue about how many people are actually talking about vaccines? Because maybe there's a lot of very biased tweets, but this is only like 0.0001% of all tweets. And then is it still relevant?
Yeah, good point. So the selection of tweets happens with a very complicated queries. So we don't have classification of relevant and irrelevant tweets because that would require a model per se. We just have queries that require specific keywords to appear, COVID vaccines. In the queries itself, we can filter by geolocation. So we know that all the tweets come from actually the country in place. That's another problem of Twitter. That very often people talk about other countries from everywhere. And you want to select from a country, but the Twitter API allows you to do that. And sorry, what was your last concern about?
Well, if you only take the ones that have hashtag vaccine or hashtag COVID-19, then do you
Yeah.
get also an image of how important this topic is on
Ah.
Twitter in general?
True. Yeah, so you can. We didn't focus on that, but you could, of course, by looking at the general traffic. The problem is that if you want to say compare um, if you want to compare COVID vaccines with other topics, you need also to collect tweets on other topics, and then the volumes quickly start to explode. And then volumes come at a cost, both of processing and storage. So yeah, so again, for the sake of simplicity, we deemed it out of scope. But that's actually good, because it's a good point. There might be a lot of misinformation, but if it's negligible streaming in Twitter, I think for COVID vaccines we don't have the risk of this, right? So I don't know. I think everyone assumes that that's an issue that people talk about. But for other, if you apply the same to other contexts, yours, I think it's a very relevant concern.
All right, thanks.
Thanks.
All right, Andrew.
Yeah. Again, thanks for the talk, Jacopo. Yeah, so I want to build on what Mirzat was talking about. So you shared that you really don't want certain people to be linked back to sharing misinformation, because that's potentially damaging, and it's also potentially dealing with personally identifiable information. At the same time, you've got this competing goal of wanting to address the right issues at the right time in the right place. So from this ethical context point of view, do you have an opinion on doing these kinds of network analyses that you talked about with retweets and likes to get insights into localizing what the super spreaders of misinformation are, or going further than that, targeting people that have bought into the misinformation for campaigns for spreading the right information? It's a very open question, but
yeah, it's a very good one. Because what you say, targeted communication and identification of super spreaders or influencers, depending if you're talking about the virus or information. They are, I mean, these techniques are used by marketeers on a daily basis. There are tools to do that. The knowledge is there. It becomes more, I would say, of ethical and political choice, to which I don't think I'm in the position to answer for the Red Cross movement. So I can only give you a very personal answer. I personally think that there are many concerns that we should be taken very seriously, but we should not exclude a priori the possibility of really moving towards targeted communication, which is not what we do. When I say targeted, we still make surveys. We take a snapshot of the society, and we can make it geographically. We can make it, we can break it down in subgroups. But it's still a survey. It doesn't really target individuals based on networks or based on everything that you said. So that's, I would say, another step. And I think the reason why we're not there yet is that there are many serious concerns which are not fully addressed, ethical concerns. Yeah, the knowledge is there, the technology is there, so they should not be excluded a priori. I don't know what to say. It will require a separate talk, I would say. What can go wrong? And maybe I'm not
definitely.
Yeah.
Thanks.
Yeah, maybe Kate will address some of this. I had the same question actually. If Bob spouts all the misinformation, you want to call Bob, say like, "Hey, what's up?" But I understand that there are ethical concerns.
Bob was good, huh? Oh, let me go back. Bob says vaccine saves lives. He's getting shot in Manila. Bob is good.
Sorry, then it was Jack. Yeah, but so that was one question. So, but the other question is, maybe I missed it, but how exactly is the dashboard used on the ground? So I mean, say you see, okay, there's some misinformation in that region. Does that mean that then that region is called more frequently, or it's like, what's the intervention that is, that is being?
Yeah, so the Red Cross is within each nation is also built in a federal way. So you have local chapters of the Red Cross in the different provinces. Now, the communication campaigns, they follow this hierarchical structure, so to speak. So there are central themes that are maybe decided at the headquarter level. And then the individual chapters, they do their own communication work on social media or whatever, well, based on the demographics, they can be different social media, whatever they do, can be mails, whatever, websites. And the communications teams, they coordinate with each other on which messages to send and when. So this kind of information is what they talk about when they decide which topic are we going to address in our next post,
Right.
very concretely.
Right. Nice.
Yeah. So
yeah, very cool. Yeah. Okay, we have a lot of questions still actually. So I just let Gina and Alonso, who haven't asked a question, and then we move on to the next speaker. I think Jacopo, if you're available afterwards, maybe you can walk around and gather town for everybody. So Gina, if you want to go ahead.
Yeah, I was just wondering what constitutes a rumor. Like, how do you detect that a tweet or like a series of tweets are related to a specific rumor? Do you have, like, I understand that you detect the sentiment or the topic, but do you have like a list of keywords that identify a rumor, and then you detect tweets that contain them, or how do you detect rumors?
no, sorry, maybe it was not clear enough. So the set of keywords identifies tweets about COVID vaccines. The way we identify a rumor is through topic modeling. So we do this, we create these clusters, and some of these clusters, they clearly talk about an issue. They clearly talk about, I don't know, corruption in the government because the vaccines, whatever, they're being bought at a surplus and someone is making money out of that. Or they clearly talk about conspiracy theories. Now, of course, the problem with clustering is that the more granularly you go, so yeah, it's a compromise between summarizing the corpus and going granular in the specific topic. That's a human decision, which is done at the moment. And that's some of these clusters we identify as, okay, these are the rumors. And then we try to translate it in a human readable way. I hope it's clear.
Okay. Sure.
Excellent. Alonso, you get the last question, and then we have to move on. If you're here.
What a privilege. Thank you,
Yeah.
Jacopo. Can you hear me well?
Yes.
So I was wondering about three different things. So I'll just put it in short in two blocks, and I hope this will be quick enough. I was wondering first about false positives, how you treat, for example, people. I will just put it in an example. In the last press conference, President Biden said something like, referring to the situation on the border, he said, it's sick. Okay, if you capture it's sick in the context of the border in Mexico, obviously that's a negative sentiment. But if you put it in the context, for example, in a chit-chat talk in Britain, it's sick could actually mean it's great. So how do you deal concretely in your model with those type of false negatives or false positives? Do you do that, etc.? Or do you just swallow it? And the other one is a high-level question, and I just wonder whether there's this idea of bullshitting people could be both intentional or just because of lack of knowledge. You could unintentionally say, I don't want to get my COVID vaccine because otherwise I will test positive on my PCR test, and I don't want to face that situation in the airport. But you're giving away bullshit that was put in your head, and you innocently believe it. So you're not actually intentionally spreading misinformation. You're just spreading what you think is true. And the high-level question is, do you think that sentiment analysis and the type of analysis that you're doing, whether you could spot this type of intentional versus innocent bullshit spreading? Thanks.
So regarding the limitations of the sentiment analysis, I don't think the models, so as I mentioned, we use Google models for that, and I don't think they have any fancy mechanism to distinguish irony, sarcasm. Sorry, Alonso, I think you are muted.
I think you muted Alonso.
Sorry. Yeah, that was sorry. That was my finger being too quick.
Okay. So there is no, I think, fancy trick behind the hood, although Google
Okay.
models are proprietary, so I cannot tell you the specifics.
Yeah, of course. Yeah.
The state of the art, but I don't think they detect irony or the case that you said. It's just going to have a negative sentiment. So that's noise
Right.
for us, and I don't think there is a way to detect it. Regarding intentionality, so of spreading fake news, you might study that with these kind of tools, but we don't care so much. So if someone does it intentionally or so naively or intentionally, it's still misinformation spreading, and that's still something that should be addressed. So we can.
There you go. It goes back a little
differentiate.
bit to Merzat's point. Yeah.
Yeah.
Yeah. Thank you,
Okay.
Jacopo. Thank you for the very interesting talk.